Welcome, everyone, to Mark Voids a Warranty. It has been a little while since we've been together. Hope you all had a good week and you broke something. I don't know. Well, today I've got a treat for you. This is something that I used back in a former life, and it is kind of a neat way for a teacher to keep track of what's going on in their class. So it's a little writing pad and a little touchscreen LCD and the associated charger. But the cool thing was what went with this. This goes with little remotes that you would give students, and you would give one to each student. So as you went through your lesson, you could check for understanding immediately. A lot of fun. Very, very cool technical feature there. It is a little outdated, unfortunately. I might still see if there's some parts in here I want to, or even keep the whole thing together. We'll see. But that kind of doesn't really go with the whole Mark Voids a Warranty plan, now does it? So as we go through this today, we are going to basically slowly take this thing apart and see what happens. So, Moby, there was nothing wrong with you other than you got old. Don't know what to tell you. It's neat bit of kit right there. I'll tell you that much. So, with that, let's go ahead and see if we can't get started. Let me get a transition going here. We'll get an overhead view. This is what we're looking at. It still turns on. It's a little mad because I don't have the software anymore or the little receivers to go with it. But this is one of those things where they ask you to sit through a sales meeting to get something for free. I did, and I did. So anyhow, neat bit of kit. We'll see if the parts can't have a second life. So the first thing I'd like to point out is that this came with a charging stand that it sits right on it. And you probably can't see, but there's little pogo pins right here, little spring-loaded pins, and there's two for each receiving point. So these parts are not spring-loaded. They're just little brass whatevers. They got soldered studs. They got soldered into the board. And then over on this side, you've got a USB cable and charging circuitry that would allow you to get power into the thing. So easy peasy. And then storage, you just set it right on it. I don't know. I gotta say, I like it. I like it. So with that, let's get going. It has been all sorts of fun in California this week. Keep getting heat waves that we have to deal with. Now, I'm lucky enough to live near the coast where that's not such a concern, but it still does make being outside a little less comfortable than I'd like. I think the screwdriver might be a little bit small. Do I have another one? If not, I gotta change. No, let's change. I've got this little set that I just keep going back to time and time again. For taking stuff apart, it just seems to be the right amount of everything. Let's see which one fits. It's a little too big. As I go through here, if any of you out there in the viewing audience want to ask questions or leave a comment, please feel free to. Who knows? I might even notice it. And I would also, while I'm taking this apart, encourage you to talk to your friends and neighbors and get them to subscribe to this channel as well. Once we hit 500, I've got a really cool teardown. We're already more than halfway there. In fact, we're just a hair over 60% there. So I'm guessing this houses the rechargeable batteries. And I gotta say, what kind of excellent engineering must have gone into this that I haven't turned this thing on or charged it in 4 years. It can still power up. The engineers that came up with the power saving mode on this thing really went out of their way. I give my hats off to you peeps. And this is a 4,000 milliamp hour 3.7 volt battery that still has a charge. I have to say, good on you. Good on you. So now I'm just making sure I got all those screws loose. Might be able to flip it and get a couple of them out. Okay, that's all of them. So now we should, oh, I guess I should take the pin out. Might have to cut that off. In fact, let's go ahead and do that. Do. All right. Now, nope. No other screws hiding in there. Under that little replaceable pin pad there. So it must just be snap clips holding it together at this point. Little... I don't know. I could be wrong here. That feels like more force than it should. Are there any more? Well, there's some feet here. Sometimes screws are hidden under feet, but usually they don't go to the trouble to do that if there's other visible case screws. Nope. That got me little of nowhere. So again, I'm still trying to get into this. Yep, there's clips. Okay. So with that, I've also got a cable I've got to undo. There we go. Okay. So what we've got over on this side is something that charges the battery, and it's just two, it charges the battery and the pin. So there's two metal contacts that intercept two metal rings that control the charge, or they're conductors into the battery there. So simple, but effective. Then we've got two PCBs. One looks to be the wireless, so they probably got a separate module there. So we'll take a look at that in a minute. And then we've got the PCB along with some big open vias, maybe for testing, and some other, probably for programming testing. So let's keep going. Okay, so once you know how to get into this thing, it's actually pretty easy to get into. It's just figuring out how to get into it in the first place. That's free. Oh, this is going to be fun. All right, and then on this side, I've got 2 ZIFs that are holding the touchscreen parts together. So that'll be fun. We'll take a look at that in a moment. And then we've got the board with the display and all that other good stuff. Interesting, interesting. So let's, I guess, let's dig in. Let me figure out a place I can set that for a moment. And then you guys probably, at this point, I would assume, want a little bit of a better overhead shot. I mean, something where you can see what's going on a little more. So let me see if I can't figure that out for you. Oh, wrong macros. There we go. All right, so now you have the overhead view. And here is our board. And one of the things, the first things I wanted to point out is just organizational. You know, here they are keeping track of their PCB and assembly revs. I mean, right there. That's nice for version control and figuring out what's going on and all that. So I said there's 2 PCBs, so we've got one here that appears to be the wireless communication module. And the reason that it's sometimes nice to do that separately is you can upgrade, downgrade, make things compliant for, you know, different countries or, you know, whatever you want to do. They could, you know, easily replace this with, you know, if Bluetooth wasn't available, something else in the ISM band without much issue. And they've got a reverse mount female header. I mean, those things are pretty narrow. Looks like, oh, I'd hate to guess, but that's pretty small pitch. You know, that's either 0.05 inch, 1.27 millimeter, or might even be a little smaller, like a millimeter. I don't know. And then if we wanted to pull that out, is there anything preventing it? I don't think so. But it really is in there pretty good. Let's see if a little torque will do anything for us. Nope. Oh, there's adhesive. Who wants adhesive? Double-sided sticky foam. All right, so there we go. Not the easiest thing to remove safely, but it's probably safe enough. Okay. So starting with this is a thinner than your typical board, and sometimes they'll do that for impedance and signal integrity issues. If you have a thinner board, you've got tighter coupling, and it's easier to work. And as long as you stay north of, you know, the 0.8 millimeter or the, what is that, 32 mil, don't quote me on that, minimum, the board's still stiff enough that it's pretty easy to fabricate, and it doesn't end up being much of a problem. So here we've got just a regular header. Down on the bottom, it looks like we've got our programming header. They opted for vias rather than pads. That's no big deal. And it looks like there's a part here that is potentially missing. I don't know what might go there. Does it say anything? No. I mean, 4 pins could be almost anything. I squared C, RS 232, UAR, just typical UART. I mean, it could be a little bit of anything. So, a couple things that I do notice, and they're pretty standard fare. You've got a bunch of vias up here. Why there's 2 rows, I don't know. But it looks like they were trying to create a via fence, something that would prevent the RF signal from entering the board from the antenna here. I think that was their goal. Let's see if we can't pull it up on the microscope and get a better view, yeah? Let us see if it's doable. All right. Hopefully that's clean enough for you. So one of the things that's odd, though, is kind of I wasn't quite sure when I saw... I noticed this a minute ago, but I wasn't quite sure that I was seeing what I was seeing just because it was so small. But it's kind of a slapdash via fence, right? It looks like it's a combination of vias that are those filled or tinted, or are those micros? What's going on? I don't know, but it's not really in a line. It's weird. Usually it's harder to not put them in a line on a grid than it is to put them on a grid. But here's something I do like to point out every time that I see it, and I am looking at this via right here as the offending via. See, you notice that holes are never drilled dead center. There's lots of reasons for that, but let me see if I can actually zoom in on this for you. All right, so the drills always wander, and if they wander in the wrong direction, it can actually break the copper. So here you can see that the drill wandered down. You don't get to control which direction the drills wander, because ideally you always want them centered. But had this drill wandered left or right, it would have completely broken this trace and ruined this board. You would have had to toss it in the trash. So whenever possible, I always recommend that people fillet their via, or fillet, fillet, I'm going to get people yelling at me over that one. Fillet their vias. Basically extend with teardrops would be another way. What's the other word? Keyhole is the other one. But basically you put more copper into the junctions so that if this drill wanders in the direction of the trace, there's metal there for it to go into, right? What would have happened if this had wandered up in this direction or down in this one? You would have been toasted. So on that one trace, we've got 1, 2, 3, 4, 5 opportunities for failure that wouldn't have been there had the designer included teardrops or rounded those things over or even done keyholes. Another thing you can do if your software doesn't allow you to do that is you can simply neck down. That's perfectly acceptable too. You can probably hear Angry Chester over there in the corner. He says hi to everyone. All right, now here's exactly what I was talking about. See, if it goes in just the wrong direction, it can kill your board. Look how little copper is present there. I mean, we've got an annular ring that's down to, you know, I don't have this a scale on this calibrated for you, but that's got to be well under a mil, half mil area. This thing was on the verge of failure, and it will fail eventually in its lifetime. And wouldn't you hate that to be the stupid reason why, where you could have just included a tiny little bit of copper and you would have been just fine. But it's something engineers often forget to do. For Class 3 devices, IPC allows a minimum remaining annular ring of 2 mils on exterior pads, 1 mil on interior pads. For Class 2 fabrication, this can actually break out up to as much as 90 degrees and still pass inspection. We also see schmutz all over this board, which is flux that didn't get cleaned away. More via issues. That's some of the adhesive that I was fighting with. It's a little microchip pick device that's running this. So, all right. Well, with that, let's move over to the board. So, I'm guessing whoever designed that little Wi-Fi module, or probably not Wi-Fi, it's probably, well, maybe it is Wi-Fi. I don't know what it is. But whoever designed this is going to be way different than the guy who designed the rest of it. That's my suspicion. So let me zoom out a little. We'll do the wide view first, and then we'll come in. How's that looking for you? Sorry about the bouncing. There's very little I can do about that. I've got my microscope counter cantilevered about 3 feet. So the first thing I'm taking a look at is you've got all of these vias, and they're unpopulated PTH that I'm sure were never meant to be populated. These were probably just for testing. So you hook up spring-loaded probes and program your boards after they're all assembled and all that other good stuff. So one of the things that you can see right away is that the designer here used copper pores everywhere. It's something that I like. It's a good thing. If you have even amounts of copper in your stack up, and you came up with a balanced stack up where the coefficients of thermal expansion are relatively consistent across your design, then your boards, your panels tend not to turn into a potato chip during reflow. It's a bad thing. You can't put flat parts on a curved board, or at least not very well. But one of the things that you have to look out for when you do something like this is that you have to stitch the copper pores on the various layers together. Otherwise, you can end up with an antenna. Even if you didn't mean to design one, it ends up going there. So here they've done stitches. They're not that common. Every couple 100 mil or so, they just set up a grid and just dropped them in and tied them to whatever net the copper pore is. It's usually a ground. You can see, where is my, so you see these little slivers of copper that connect this plated through hole part to the rest of the copper pore. The reason that you do that is that this copper pore has an incredible ability to source and sink heat, right? It can just move it right away. So if you don't do that, if you don't create some sort of a thermal break, when you try to heat this up to solder it, you just end up heating up the whole dang region, and you never get that pad to temp. So that just kind of slows the heat transfer down so that the heat stays in the pad. And these guys are for the power button. So maybe we'll take a look at that circuit in a minute. It looks like the designers included, let me find my thing, parts for a crystal or a crystal oscillator that they never bothered installing. So they probably found out that they could run off the internals just fine, the internal clock. See a lot more schmutz on the board, more evidence they didn't clean stuff. Slackers. You should always clean your boards, even if you have no clean flux. That doesn't mean you have a no clean board. Manufacturing is a dirty, dirty process. So nothing around here strikes me one way or the other. It's just pretty standard practices. Except for the way that they laid out their capacitors and resistors, you don't see that with the vias all that often. I'm guessing those are decoupling. Maybe they put in big vias for lower impedance. I don't know. I don't know what they were doing there. Those are big vias. I don't have a problem with it. I'm not saying it's good, bad, or indifferent. I'm just saying I don't know why they went so big. I've got, like I said, no problem with it. I just, maybe it's just personal preference. I tend to go a little smaller on my vias, and I've gotten away with it. So maybe they got bit by a previous project and decided to do things a little different. Maybe they wanted to see different specs. It's interesting. It's almost the pattern for an RF antenna. I mean, overall, a very cleanly laid out, very clean board, except for the flux part. I don't mean it's physically clean. I mean the design is clean. And this appears to be stylistic. They brought the solder mask back from the edge, so you'd have an Enig edge around. Is that stylistic or is that functional? They didn't do it at the bottom, they just did it at the top. But it's not stitched in a via wall. In fact, the vias there are spaced out considerably. I'm going to go with stylistic. Looks cool. All right, so now to the side with the screen. We can see the other side of those test pins, so it's easy to capture from either side. Usually you want, for cost saving, you want to have all of your test pins on one side of the board, but I guess this way they're on both sides, but it's not like you have to be on both sides. It's just whichever way it's easiest to design the test fixture, you can do it. But yeah, just more of the same. You've got copper pores everywhere. Again, it's something I like to see. Just simple 45-degree traces where you need to change directions. They chose not to go with 90s. It turns out for stuff like this, it just doesn't matter that much what you do. So, guessing they were just playing it safe, or just having fun. Interesting, interesting. All right, so I really have nothing else to point out there. Maybe one or two things. Over on this part of the board, this is where we got that RF thing. You can see that they did copper voids. They knew there was going to be an antenna situation going on over there, and they didn't want anything to do with it. So while there's dielectric there, there's no copper. And then you can see where the copper, you can kind of see where the copper picks back up on internal layers, but not really. I can see it. I don't know if you can see it on the cameras. And I think that's just about it. There are two chips here that are running things. One is this, whose logo I don't immediately recognize. SSD 1926QL9 AU225AS are the topside markings. And it's certainly got more than enough signal lines to run a display or a display and a touch screen, right? That's the connector for the touch screen. There's more than enough signal lines there. And then there's also a microchip chip. PIC 24FJ256. So a microchip PIC that runs stuff too. And then I don't really want to pull this display off to see if there's anything else hiding under there. But it looks like hiding right next to the connectors are HP 4067 and what's this guy? HP 4067. Come here, Chester. Oh, there you go, buddy. And these, if you remember, connected to the sensor interface. Man, my kitty cat is really mad right now. So let's get back to a wider view and take a look at those. Again, if you have any questions or comments, please feel free to ask as we go through stuff. Okay. So here we've got a metal backing plate and a grid of lines. So it looks like for the most part you've got vertical on one layer, horizontal on the other, except for down near the bottom you've got these ties where it seems like they've increased the density for some reason. And then down at the very far bottom, it looks like these things are just tied and hopscotched one over the other. It depends because the numbers change. Okay, so every so many vertical lines, these things are tied together, which then must increase the length of the trace. Interesting, interesting. So every single one of those lines then at some point comes together and then shoots off into those ICs that we'll have to identify. Here's a better view of it on the back side here. You can see a little bit more about what's going on. So my guess is that this thing sits a prescribed distance away from that metal plate. And when you run over it with your pin, either you're increasing the capacitance of the vertical and horizontal line that you happen to be touching at the time, or it could also very well be that you're somehow coupling one line to the other. I don't really know. But it's pretty common for devices like this to run a oscillator and use these traces as either capacitive or inductive or something, but they notice that when whatever property it is that they've designed this to investigate changes, they notice that that changes the frequency of oscillation. So that's interesting. But why there are these and how that would affect the... Okay, so I don't know why there's all of these ties. They look like as they come down, they split and, you know, they send the trace in one direction and then the other. I don't know. And I don't know how that might impact the overall sensitivity of the device in that area. I really don't know. But to me, it looks pretty clear that they're hopscotching these. And I mean, this thing's artwork. I really like it. But it looks like they're really hopscotching those devices over. But I've never taken apart and seen a touchpad and actually seen, you know, been able to see through it. That's pretty clever. And to be able to do that whole area with, I can't really count that, maybe you can, but that's not a lot of connectors. Is that maybe 20? I'd have to pull out the microscope to see it myself. But that's not very many connectors at all. And this whole overall area is huge. How interesting. All right. Well, we still have a little bit of time. I probably don't want to take that apart if I hope to put this back together. But I don't mind taking this part. So this is the charging base, and we're going to take a look and see if there's anything of interest in it. No. The answer is no. There is nothing of interest in it. There is... So I don't know if you guys can actually... you probably can't see this. This is just a USB cable that they've glued into the base. So they designed around this. So all they've done here is broken out the power supply from a typical USB cable. Nothing too exciting there. Okay. And then my always favorite thing to see, a value-added mass. Although, in this case, I'm guessing they just put the weight there to keep this from sliding around on somebody's desk. That's what you always hear. But I'll cut them some slack. The rest of it seems to be designed well enough that we don't have to give them any crap for this one. All right. Well, that was the e-instruction Moby 360. And I think I'm going to put this back together. I don't know that these things are still in use in a school, but I might go drop it off at a nearby school and see if they can make use for it. Other than that, it just seems a shame to throw something that's still working away. I mean, hopefully that thing still has a few more years of life in it. All right. Well, I am going to go do the Southern California thing and find a swimming pool, and I will see you all next time. But before I go, I would also like to let you know about something else that we're trying out. It's called Mark Makes a Mess, where I go around and I just try to put stuff together and something always goes wrong. It should be fun. Come check it out if you ever see it live. And if you do have any questions, comments, concerns, or you need some help making your next PCB, visit Advanced Assembly.